Hello, welcome to the lecture on alias structure in fractional factorial design using regression. So, that means you require a defining relation, either one defining relation or two or more defining relations, and then those defining relations will help you to identify the alias structure. That means, what are the effects that are confounded, that is known. So, it may so happen that there will be certain situations when you may not get the defining relations, and another one is that under certain simple condition these defining relations work well. There may be situation, complex situation, when the defining relationship will become complicated and you may not be able to get that desired one. So, alternatively you can use regression approach to find out the alias structure. In this half an hour lecture, I will show you how regression approach will be used to find out the alias structure, and with two small examples. I told you the motivation is that there may be situation when which will be complex, design will be complex. For example, non-regular fractions, and there are situations where design is simple, which is regular fraction. For example, if I consider to the power k minus p, and then which is basically to the 1 by 2 to the power b to the power k design. So, that means 2 to the power something, this kind of design is the regular design. If p equal to 4, then it is basically 16 runs. If p equal to 3, it is basically 8. But suppose a design where we are interested having the 12 experimental runs, it can be represented in terms of 2 to the power p. This is irregular design, irregular. So, under irregular design case, so defining relationship will not work, and again in some cases the defining relationship is not available, like that is Plackett-Barman design. So, under such situation, how do you find out the alias structure, or how do you estimate the parameters when you go for fractional factorial design? That is the discussion point now. Suppose you have k factors. So, a, b, c, d, like up to k factors you have. So, correspondingly we can say we have x 1, x 2, so like the x k variables, So, you can fit a equation main effects model, let it be only the main effects. Y is basically let it be beta 0 plus beta 1 x 1 plus beta 2 x 2 dot beta k x k plus epsilon. Let we will define it like this. This is nothing but x 1 beta 1 plus epsilon, where y is n cross 1, n number of observations, x 1 is basically n cross p 1, suppose p number of effects. When we use only the main effects, intermediate effects are not considered. So, that means p number of parameters considered here. Beta is p 1 cross 1 number of effects to be estimated, and this is n cross 1. So, you know that in this, if I write down, then under this situation beta 1 cap is equal to x 1 transpose x 1 inverse x 1 transpose y. That is the formula you have used earlier. So, this is we are saying this is the model you have considered. Now, if I go for fractional factorial and design analogy here, what happened? You have considered only the main effects, all interaction effects you have ignored. Okay. So, that means they are in this design interaction effects are not significant. But maybe the full model is a different one. The full model or the true model probably y equal to beta 1 x 1 plus beta 2 x 2 plus epsilon. Then what is your beta 2? This may be p 2 cross 1. The remaining factors which are not included in the model considered, which is true for the true model which is considered, and then this may be n cross p 2, the additional design matrix. So, x 1 and x 2 this combine the full design matrix, but it is additional design matrix. So, if this is true, what will happen then? What will happen to the expected value of beta 1? What is expected value of beta 1 cap? You all know it will be expected value of x 1 transpose x 1 inverse x 1 transpose y, because beta cap is this. So, then if you write down this further, then this will be x 1 transpose x 1 inverse x 1 transpose. What is the y true value? Y true model is this. So, you write down it, this is as beta 1 x 1 beta 2 x 2 plus epsilon. So, then this will go to as x 1 transpose x 1 inverse x 1 transpose x 1 beta 1 plus x 1 transpose x 1 inverse x 1 transpose x 2 beta 2 plus x 1 transpose x 1 inverse x 1 transpose epsilon. So, x 1 transpose x 1 into x 1, this is I. So, you can write this as expected value of beta 1 plus this is the fixed quantity will come out x 1 transpose x 1 inverse x 1 transpose x 2 expected value of beta 2 plus x 1 transpose x 1 inverse x 1 transpose expected value of epsilon. So, what will happen? This will be beta 1 and this will be x 1 transpose x 1 inverse x 1 transpose x 2 into beta 2 plus 0, because expected value is 0. So, this quantity if we put at A, then this is beta 1 plus A beta 2. This A matrix is known as alias matrix. A matrix is known as alias matrix. So, using regression approach, you are able to find out the alias matrix. Now, let us see with an example. The example is 2 to the power 3 minus 1 design. 2 to the power. So, example is 2 to the power 3 minus 1 fractional factorial design. Number of factors A, B and C. Defining relation I equal to A, B, C, or we can write x 1, x 2, x 3. Okay. So, under this situation, what is the design matrix? So, it is 2 to the power 2 full A, B and C. Okay. A, B and C, and I will also be there. So, I will write here, this I will write I, this I will write A, this I will write B and this I will write C. But you have how many observations? 1, 2, 3, 4. So, I will be all plus 1, then this is minus 1, plus 1, minus 1, plus 1. this is -1 plus 1 plus 1. Let for the time being, suppose now you have to choose the where you will keep that C, which one is where it is plus minus this thing. So, let us assume that using this concept C equal to, if it is AB, we will assume the same thing to show that it is coming from regression approach also to prove it. So, that means C is plus 1 minus 1, this into this minus 1, this into this minus 1, then plus 1. Okay. So, what is my design matrix then x1? x1 is 1 1 1 1, then minus 1 plus 1 minus 1 plus 1, then minus 1 minus 1 plus 1 plus 1, then your plus 1 minus 1 minus 1 plus 1. This is my x1, and let the corresponding y regression model is y equal to beta 0 plus beta 1 x1 plus beta 2 x2 plus beta 3 x3 plus epsilon. Then beta 0 is our beta 1 is beta 0, beta 1, beta 2 and beta 3. So, 4 cross 1. So, that means we have considered a model y equal to x beta 1 plus epsilon, where y here is 4 cross 1, this is 4 cross 4, this one is 4 cross 1, this is 4 cross 1. Okay. Then what you have not considered? You have not considered the second order interaction. Third order interaction, one third order interaction is already interacted with the confounded with the average. So, remaining part is the all the second order interaction part is not considered here. So, that means if I consider that my true model is y is x1. So, this is x1, sorry, this one is x1. So, now if we consider that x1 beta 1 plus x2 beta 2 plus epsilon, where x2 talks about the other terminology. So, what is the full design? A, B, suppose C, A, B, B, C, A, C, A, B, C. So, what we have considered? We have considered A, B, C only. So, that means this portion you have not considered. You have I equal 1, 2, 3, 4. This is what x1 is considered, but this is x2. Now, this is x2, ABC is equal to I with the beta 0 part. So, now if the true model where basically x2 is this design matrix and beta 2 is basically the all the interaction parameters. So, then our y is beta 0 plus beta 1 x1, beta 2 x2, beta 3 x3, beta 1 2 x1 x2, beta 1 3 x1 x3 plus beta 2 3 x2 x3 plus epsilon. So, suppose this is our full model. So, under such situation what will happen to beta 2? Beta 2 is your beta 1 2, beta 1 3 and beta 2 3. What about x2? x2 is this 3 by 4 that. So, you know A, B, C is known. So, A, B, B, C all those things you can write down as A, B, C is known, A, B, B, C all those things can be found out accordingly, and that value is basically 1 minus 1 minus 1 plus 1, then minus 1 minus 1 plus 1 plus 1, then minus 1 plus 1 minus 1 plus 1. So, this is our. So, that means beta 1 2, that is A B, then it is A C and it is B C. Okay. So, if you use the first model, if you use this model where the true model is this, then definitely the alias structure is there. What is this alias structure? So, you all know A is the alias structure, A is the alias matrix, A is the alias matrix. So, this one is x1 transpose x1 inverse x1 transpose x2. So, what is your x1? Your x1 is this. What is x2? x2 is this. So, x2 is 4 cross 3, x1 is your 4 cross 4. So, now you find out x1 transpose x1 inverse and also find out x1 transpose x2, multiply the 2. Okay. So, now what is x1 transpose x1? Let us see. x1 is, or I can write x1 transpose x1. So, we can write 1 1 1 1 minus 1 plus 1 minus 1 plus 1 1 1 1 1 minus 1 plus 1 minus 1 plus 1 minus 1 minus 1 plus 1 plus 1, then plus 1 minus 1 minus 1 plus 1. This is x1 transpose. Then what is x1? 1 1 1 1 minus 1 plus 1 minus 1 plus 1 minus 1 minus 1 plus 1 plus 1 1 which one? This one, plus 1 minus 1 minus 1 plus 1. So, if you multiplied this, what you are getting now? All 1 into 4, so you will be getting 4. This into this, then this into this plus, and this into this plus minus will cancel out. So, ultimately you will get 0 0 0 0 4 0 0 0 0 4 0 0 0 0 4, which is 4 into I4. Okay. So, what will be then x1 transpose x1 inverse? It will be 1 by 4 I4. So, in the same manner you will find out x1 transpose x2 value will be your like this, will be 0 0 0 0 0 4 0 0 4 0 4 0 4 0 0. You will get. Now, if you multiplied now x1 transpose x1 inverse x1 transpose x2, which is A matrix, what you will be getting, that is of importance. Let us see the slide, that is better. You see that A is x1 transpose x1 inverse, which is 1 by 4 I4, into x1 transpose x2, which is this. If you multiply these two, you are getting this one, 0 0 0 0 1 0 0 1 0 1 0 and this thing, and when you multiplied with this beta 2, then you are getting this, and allowing this, you are getting this. Okay. So, then what is the final one? Final one is your expected value of beta 1, which is your expected value of beta 0 cap, beta 1 cap, beta 2 cap, beta 3 cap. This you finally got beta 0, then beta 1 plus beta 2 3, beta 2 plus beta 1 3, and beta 3 plus beta 1 2. That is what you are getting. Okay. So, it is a just matrix multiplication at the end. So, I am expecting that you will be able to find out 1 by 4 I 4 into that x 1 transpose x 2, that value, and that value is nothing but 0 beta 2 3. So, that value means what I mean to say 1 by 4 I 4 into x 1 transpose x 2, this value is nothing but 0 beta 2 3 beta 1 3 and beta 1 2. So, 0 beta 3 beta 1 3 sorry with reference to your this multiplied by obviously the beta 2 part 2 3 beta, let us write this beta value only, beta 2 value. What is the beta 2 value that you already seen? Beta 2 values are your beta 2 first equation, this is what is beta 2. Okay. So, I am sure that you will be in a position to compute it. So, this is what is our now alias structure. Okay. So, now if I go back to the power 3 minus 1 design where I equal to a b c. So, what I got multiplied with a, this equal to b c, b equal to a c, c equal to a b. Now, I want to relate this with this. You see a equal to b c is not this is not beta 1 plus beta 2 3, is not the second one is this beta 2 plus beta 1 3, is not the third one is this beta 3 plus beta 1 2. So, that is what is the regression approach for alias structure determination. Okay. So, let me read out. Each of the main effect is aliased with one of the two factor interaction which we know to be the case in this design from using defining relations. That is what I have shown here. Every row of the alias matrix represent one of the factors in beta 1. Alias matrix, if you see what is this alias, this matrix, and then every column represent one of the factors in beta 2. So, there are 4 every row for beta 1, that is the 4 factors, 4 parameters, and beta 2 case there are 3 interaction parameters. So, 3. Okay. Now, let us see another example. Suppose you are considering to the power 4 minus 1 design. Here there are 4 factors a b c d, and you also know that here what will be the a b c d will be I. If you consider that d equal to a b c, that a b c d will be I. In the same manner, if you multiply this you will get this design. If you do not know, but you can use that minus plus some way, and ultimately you will get the alias structure using regression equation. That may not be the good one, but it obviously if you choose D effectively, the best one you will be getting. Now, suppose we are basically considering that only the main effects are interested, and the other things we are keeping under x 2. Okay. So, suppose that the first model like this reduced model is not good one, actually it is the total impact is there. So, then what you will do, you will find out the alias structure by using x 1 transpose x 1 is this and x 1 transpose x 2 is this, and then x 1 transpose x 1 inverse is 1 by 8 into I 5. Here it is I 5 because you see a b c d and I. So, that means that 5 cross 5. So, that is why 8 8 8 8 these are coming, because it is to the power 3 full to the power k factorial. Okay. So, then x 1 this matrix, if you see that, you will see that the first 1 2 3 4 5 6 this column there everything is 0, and later on we will see that these are related to the 2 OA interaction parts, that AB, AC, AD, BC, BD, CD like this. So, if you find out beta 1 here, basically please remember this beta 1 is the main effects part. So, then if you find out the expected value, then using the alias structure 1 by 8 I5 x2 x1 transpose x2. So, this one, if this is the alias structure, you see what is happening here in the two-way interaction parts, there is nothing, only 0, and three-way interaction part there are some values. And once you complete this matrix multiplication, you are getting that beta 1 is this, is not the same thing what we have got into the power 4 minus 1 with I equal to a b c d. If I equal to a b c d, you multiplied by a, this will be b c d, multiplied by b, it will be a c d, multiplied by c, it will be a b d, and multiplied by d, it will be a b c. Is not the same? Yes, this is the same thing what you are getting here. Here also we have used a b c d like this just to show the one to one relation, but otherwise you can use beta 0, beta 1 2 3. So, this is beta 1, beta 0, beta 1 plus beta 1 2 3, beta 2, beta 1 3 4 like this. So, main effect are aliased with three-way interaction, and here you see no two-way interactions are aliased with the main effects, and that is what we have seen earlier also. Suppose we do in a different way. Suppose we are interested only in the interaction effects in the first model, and maybe the remaining part is coming under another part. And in the same way, if you find out the alias structure, and then what you will get the alias structure of this, and when you find out the expected value of the interaction parameters, where beta m represent two factor interaction parameters only, a b, a c and a d here, a b, a c, a d, we have not considered the b c, b d and other things, let it be, we have considered only these three. So, then what is you are getting a b is expected value of beta 1. Just let me go back. Yes, we have considered only 3, a b, a c and a d. So, then you see that these are interacted or aliased with other second order interactions. So, half two-way interactions are aliased with another half two-way interactions. That is what you can see using defining relation also. Okay. So, this is the way you have to understand that under a situation when you do not have a defining relation, or it is basically a irregular one, then the design is irregular, then what will happen? You may face problem in finding out the alias structure, and the regression approach is useful one, and you please follow it. So, to conclude, I can tell you that fractional factorial design is very important. So, 2 to the power k minus p fractional design is the general one, and you will find out that when we write 2 to the power k minus p, it is a regular one, but there is no guarantee that you will be going for always design which is 1 by 2 to the power p fraction. It may be situation where you want a suppose 1/12 fraction. So, in that case what will happen? It will not be a regular one. So, there will be regular and there will be fraction non-regular fraction. Okay. So, regular and non-regular fraction. So, non-regular fraction case defining relationship will be complex. There are certain other design like Plackett-Berman design. Okay. So, in this design what you will find out that the defining relationship does not exist. So, under such situation, suppose if you do fractional factorial design, how do you get the alias structure? That is what the regression approach we explained here, regression approach. And how you will do regression approach here? It is basically you think of a reduced model and then a full model or a better model, ideal model, true model. And then under true model, find out the expected value of the parameters considered in the model, actual model what you have used. So, then you will find out that the expected values are aliased accordingly as per the theory it will to be made, and that's in that way you will get a alias matrix, and using alias matrix you will be getting the alias structure. So, that is what is for this lecture. So, be very careful, read chapter 8 of Montgomery very seriously, and in fact, all the chapters of Montgomery design analysis of experiments which are under this course must be taught by you. You must read, because what I am giving you in this lecture, they are from that book, and it may so happen that some of the things you will not understand in just by going to the first by listening fast for every lecture. You require to listen several times, this is one. You require to read the text given in that book, second. Third one is you require to solve the exercises given in the book. And fourth, even if that you will do not understand some of the things, better you Google it, you will get some information, but be careful that the Google information, there will be lot of junk information. So, you use effectively the forum, pose your questions, we will answer you. Okay. Thank you very much.